The GS20 DuraPulse drives make it super easy to display the motor speed and RPM. But there's a couple things you need to be aware of. The GS20 naturally starts up showing the drive's frequency setting, the frequency you want the drive to be at. If you hit Menu, you see the drive's actual output frequency, which is 0 right now. When you hit Run, you see it ramp up to the frequency setting at whatever rate you set the ramps to. Hit Menu again, and we see the user display, which is currently showing the DC bus voltage. We want to see the motor RPMs here. I've already set up the drive with these parameters. Some of these are just defaults. I'm showing them here because we're going to use them in this demo. Parameter group 0, parameter 4, selects what's shown in the user display. It defaults to a 3, which is the DC bus voltage, and it's indicated by a V in the display. That's this funny looking character right here. And look, option 7 is the calculated RPM, and it's indicated by a lowercase r in the user display. So let's go to group 0, parameter 4, and enter a 7 to show calculated RPM in the user display. I'll hit that menu button until we get back to the user display. We have an R here for RPM. That's a good sign. I'll hit Run and rotate the frequency knob, and sure enough, we see something that looks like RPM. But wait a minute. If I rotate the knob all the way, the display says the motor's running at 1800 RPM. But if I measure that with a handheld tach, I get this. And if I were to apply a load to this motor, it would drop even more below 1800 RPM. And the nameplate says the max RPMs is 1725. But the display still says 1800. What's going on? Well, the drive calculates it's an 1800 RPM motor because the frequency is set to 60 Hz and the number of poles is set to 4. Remember, a 2-pole motor has one north and one south pole, so it's really one pole pair. When the drive's output frequency is 60 Hz, that single pole pair is going to rotate at 60 Hz, which is 60 rotations per second, which is 3,600 rotations per minute. A 4-pole motor, like we have, has 2 pole pairs, so the same 60 Hz frequency has to service twice as many poles per revolution, so you only get half the RPMs, which gives us our 1800 RPM. But that's all the drive knows. It doesn't know how much load your motor's seeing right now, so there's no way it can tell you the exact motor RPMs without some kind of feedback, which we'll do in other videos. So it simply calculates 1800 RPM from the number of poles and scales that as you change the frequency when you're using parameter 4's option 7. But what if you wanted to get a little closer to the real motor RPM? Suppose you have a system, and when operating under normal load conditions, you measure the RPM at 60 Hz to be, how about 1763 RPM. Well, here's a trick you can use to display that. Instead of displaying the calculated RPM, which we know is blindly calculated from the number of poles, we can display this guy, which takes the input frequency and scales it by parameter 0.5. It also displays a K in the user display. Let's change parameter 4 to a 31 to do that. We want the display to be 1763 at 60 Hz, so our scale factor needs to be 29.38, so I'll enter that in parameter 5. Now if I press the menu key to get to the user display and then hit Run, sure enough, my top end is very close to the 1763 RPM we wanted. We could go back and tweak the scaling factor if we wanted to be exact, but this is close enough for our demo. But what is this? Well, that's the K we were expecting to see. The 7-segment display can't show us an actual K, so it uses this as a representation of K. You can see the full character set in this chart, which is at the end of Chapter 3 in the user manual. So now you have 2 ways to display the motor RPM. First, just show the RPM calculated from the poles, and most of the time, that'll be close enough. But if you want something closer to your actual loaded motor speed, you can display a scaled version of the input frequency value. One more thing to be aware of. The GS20 drives power up showing the frequency setting by default. You can change that so it shows the user display on power up by setting parameter group 0, parameter 3 to a 2. Now when I power up the drive, it defaults to the user display, which we set up to display RPM. Click here to see more GS20 variable frequency drive video tutorials. Click here to subscribe so you'll be notified when we publish new GS20 videos, and click here to learn about Automation Direct's free award-winning support options.